All right, Integrated Math 3 distance learners, this is the last topic of this unit. Our test is expected to be, let me look at my calendar really quick, the 15th. So I'm recording this on Monday the 7th, so about a week from when I'm recording this, but whenever you end up watching it, I'm not really sure, but September 15th is when we're expected to take the test over this content. I will send up a detailed list of the standards within that and sort of a breakdown of what you can expect to be assessed on. So let's go ahead and get right into it. This video shouldn't be too long, maybe 20 minutes or so, but let's go ahead and get right to it. So function equality, this is what we're trying to do is we have two functions and we're trying to see where are they equal, and we're trying to get the x values when that's happening. So first off, we're going to write our goal. Like if I ask you a question and I'm saying, hey, I want to know when are these functions equal to each other, your goal should be able to find the x values I'm going to underline that, you should too, find the x values. That's what you want. Your answer, they're x values. Okay, answer or answers, okay? Where the two functions have equal y values. Basically, that means that it's where they're intersecting is what we're going to talk about, but this is one way that we can phrase it. But this is the format that you're going to be seeing a lot with this, is this idea of function f of x is equal to function g of x. The y values are equal in these functions. What x values make that true? Let me put a little star here, and you can write this as well. So on a graph, which is where you're going to need, if you have to have your graphing calculator for this. So on a graph, this is where they intersect. And that's, and we're going to say x values where they intersect. I'm going to put that in parentheses. So where, what do we put? It's the x values, okay? That's really the gist of this. And honestly, finding these answers is not the most complicated thing, but we do need to practice it. You have several Delta Math practice problems and sections on there. So first off, we're going to talk about, let's say that I give you two equations. What do you need to do? Well, here's what the directions would look like. It would say find all values of x for which f of x equals g of x. That's the goal, okay? That's exactly how I listed it up above, but let's actually see what this looks like. So here are the two functions. I'm going to give you f of x, 2x plus 3. You should recognize that as a linear function. Next, g of x is x squared plus 3x minus 2. You should recognize that as a quadratic. So we know what both of these are going to look like graphed. What you need to do is you need to, we'll put down some steps here for this just to help make this simpler. We'll say step 1, graph both functions. All right, so I'm going to do this example on a TI-80 series. If you have an Inspire, hopefully you know how to graph. If you're using Desmos, I'll do a Desmos example in a second. But here is my my graph. So those that are using a TI-80, you can grab yours out. If you need to pause the video really quick and type those in, you can. But this is what you need to have in. And we are actually interested in this image here. Okay, so there's our graph. And now the note that I wrote was this: on a graph where, or it's the x values where they intersect. Okay, that's what we're looking for. So we have the intersections, but what are the x values where that's happening? Now I don't want you to just guess, like this one looks like 2, and it probably is 2. Okay, this one looks, it's close to 3, but we're not really sure. Okay, so we need a way to actually interpret this on the graph. So let's go ahead and write down this. We're going to analyze the intersection points on the graph. So I'm going to we're going to have point 1 and we have point 2. So I know those are going to be ordered pairs. So we'll see what we get. But let me show you how to do this on the TI-80. If you're on an Inspire, you just press Menu, Analyze, Graph, and then you'll see intersection. But that's what we want. We want intersection. Okay. So for those using the 80 series, you're going to press second, and then the trace button, which you'll see it says calc. That's what we want. And then you see number 5 here, intersect. That's what we're looking for. So hit enter on that. And this is similar to how we found the maximums and minimums. Where is the intersection? Well, it says, what is the first curve? I'm just going to click the blue line. That's what it's on. It's not necessarily a curve, but we're just going to hit enter. Second curve. And then it wants you to guess where it is. So I'm guessing this first point is about right here. And then it gives me the intersection. It says 2.98, negative 2.98, negative 2.58. We want to round this to 2 places, to the hundred. So 2.79 and 2.58. These are both negative, so hopefully I can remember those. We're going to say negative 2.79, negative 2.58. So they are decimals, all right? However, this is not the answer format we want. We want the x values, okay? So third step here, which we're going to go back and get the other one. Third, only capitalize. Use x values for your answer. So I'm going to write them up like this. X is equal to negative 2.79. Now I've got to go find the other one. So let's do the exact same thing. So we're going to go second trace. Let's go down to the intersection. First curve, blue, just hit enter. And then second curve, right here. I want to guess where it is, probably about here. And you can see it wasn't exactly 2, and that would matter, okay? Like on the test, you would actually need to find to 2 places, okay, those intersection points. All right, so this is 1.79, 6.58. Let's go ahead and write that down, 1.79 and 6.58. Okay. We only care about the 1.79. So this is my final answer to this problem. And that's all we really need to do. It's just where do they intersect? That's all we want. Let's do another example, a little more complex. But I'm not going to be writing out all the steps for it. So example 2, same instructions. F of x, though, is going to be a cubic. So we have 0.05 x cubed minus 0.6 x squared plus x plus 8.3. And then we have g of x, which is going to be negative. We're going to use this symbol here. Hopefully you remember what this is, maybe from last year. This is absolute value. And we already wrote this down for our parent function. So we know what the absolute value, it makes that sort of V shape. But this is our absolute value parent or function here. So we have two functions. I'm going to use Desmos for this. If you're using the 80 series, go ahead and start typing these into your y equals area here. So you can type that in. But I'm going to use Desmos, okay? And this time, I'm not even going to write down the points. I'm just going to start writing down the x values that I need. That's all I care about anyway. So this can actually go really quick, but we just want to round to two places. So I'm going to pull up Desmos here. Where did I put it? Here it is. And I've already graphed these, so you can see those up at the top left. If you want to practice doing this as well, go ahead and type yours in. What's nice about Desmos, but again, we can't use it on our like state testing or anything, but you have it at home. We can just click and it finds it for us so quickly, okay? And remember, we only want this to two places. So this first point is negative 1.2, we round that up. So that's a 6, we round up, so negative 1.24. So I'm gonna put that, so let's write that in. So negative 1.24 is one of them. Let me pull up Desmos again. 4.335, that rounds up to 4.34. And then the last one is going to be 8.723. We round that just rounds down, so it just stays a 2 there. So 8.72. That would be it. Now the reason I chose this example is because this is what your delta math is looking like. Let me go ahead and modify my screen here so that they can share. And this is sort of how you could work this problem. So we have the example here. It's the same problem. And now I want to shrink that. And okay, there we go. All right. I want to enter in my answer. So I go here, and you'll notice it says nearest hundredth. So you got to be precise with this. So negative 1.23. Now, if you just start typing all these in with spaces, it won't let you space it, but you want to use commas. If you hit a comma, it's going to give you, there's the next solution, okay? So I go to the next one, and we put in 4.33. And Desmos, by the way, is going to make this super quick. You can also hit the plus sign to add a solution. 8.72. Very fast. Submit, yes. Somehow I got it wrong. Did I forget a negative? What did I put in? Look, I forgot to round. Whoops. Forgot to round. So it will get you if you don't round. That's sort of the moral of the story here. So I'll say that I made that mistake on purpose. Let's try another one here. Oh, and it can be this fast. That's what's not so bad about these, is you can just go in and modify. Plus 0.7. We want 1.2x. And then minus 5.4. All right, that should be right. I think I got all those parts right. Okay, going down here, we want to get rid of that 1.3, and we're just gonna have an x in here now. And then plus 3.5. And what you'll notice about this one is it's only crossing once, so there's only one solution where it works. So we just gotta make sure we put in the rounding correctly. So negative 4.16. Since it doesn't cross anywhere else, assuming I typed this incorrectly, and I'm going to double check that because I don't want to get another one wrong. Not in front of you guys. That looks good to me. Submit. Okay, come on now. Why don't you submit? Come on. It's taking its time. We'll see if it'll. Oh, I got it right. Okay, perfect. Yes, so and it shows the graph as well, and you can see that this graph is matching up with the one that they had. Okay. So that's all you need to do for that. Let's talk about one more thing, and then we'll be done with this lesson. Here is here's the other assignment on Delta Math, which is just looking at a graph, and you will have one like this on your next test. So we're looking here, it gives you the functions. If you want to put them in Decimus, you can, but it's already graphed it, and you'll notice how they actually line up very cleanly on the X values. So that's what we're looking for. So on this one, I'm looking, here's an intersection. I put in -2, and then I have another one at 6. I'm gonna use comma 6. Submit. It's just where they are crossing. Okay, this one is a little bit difficult looking at it. You can see that there's some space in between, so it doesn't look like they're going to intersect again. You may need to actually use a calculator for this, but not to worry. We have Desmos. Let me clear this. I'm just going to type them in now. So 3 to the x, and then 2x squared. Oh, they do not cross ever up there. So they cross here. Nearest, this one's nearest 10th. So that's to one place. So it should be -0.5. That should work because we round down with the 2. Okay, so you may need to actually use a graphing calculator for this. Not all of them are just perfectly clean. This one should be fine. It just intersects right there. So that's -4. But you can see how quick these are when you actually get it going. And I think that there's only, you have 10 of those. So that should be really, really quick and simple to do. Okay. All right. That's going to be it for this lesson.